divided by what? By 2. Pretty cool. So if in a problem they ask you to do the left Riemann sum and the right Riemann sum, and then eventually they ask for the trapezoidal Riemann sum, are you going to sit there and actually do it? Or are you just going to get the 2 that you already got for the left and the right, add them and divide by 2 and you're good. That will be the trapezoidal sum. Pretty easy? Yeah? Alright, let's try another example here. Now we're going to add more trapezoids. Okay? Let's write down the formula so we don't have to flip it back. What's that formula? One more time, we just wrote it. Summation from I equals 1 to n 1/2 times delta x times f of a plus I minus 1 delta x plus f of a plus I delta x. Some of you had trouble typing it in? Yeah. Gotta be careful with your parentheses. If you want to put brackets like I put there, that'll maybe make it a little bit easier. Okay? So on this one, we're doing 6 trapezoids of equal height, which we know is the delta x. Let's figure out that delta x. What's it going to be? 6 over 6, which is 1, right? Let me draw my little trapezoids here. So we start at 1, and draw my bases. And then let me draw a little slant. So on your activity that we're going to do later, you're going to decide what kind of sum you want to do for the particular function that you come up with. If you do trapezoidal sums, you're going to have to cut the little candies that I give you, which might be a little bit more challenging. So that's pretty good, right? Yeah? So let's jump straight to finding the area of those 6 trapezoids. Good. That's going to be the summation I equals 1 to 6 of 1/2 times 1 times f of, what's a? 1 plus I minus 1 times 1 plus f of 1 plus I times 1. And that would be good enough to give us our answer, right? On my calculator, I don't need to put those times 1s, right? I want to save some time. Type that in and see what we get. And then right now we'll write it in expanded form. Hopefully you can do it faster this time now that you know the little shortcut. 39.667. Beautiful. So pretty close to the 40 with only 6 trapezoids in comparison to the other ones, right? Good? So let's practice writing it in expanded form. But we're going to do it using the graph. Okay? Using those values right there, right? So we know that it's going to be 1/2 times what? 1 times. How many times are we going to use the 1? Once. So to figure out that base, it would be f of what? F of 1 plus, how many times are we going to use this guy? 2f of 2 plus, how many times are we going to use this guy? 2f of 3 plus, how many times are we going to use this guy? f of 4 plus, how many times are we using this guy? 2 f of 5 plus, how many times are we using this guy? 2 f of 6 plus, how many times are we using the last one? So just f of 7. You understand? You want me to write it out separated, or we're okay with applying the shortcut? Okay? Promise? And what would that answer be for that? 39.667. It's really this. F of 1 plus f of 2, right? Plus f of 2 plus f of 3 plus f of 3 plus f of 4, so on and so forth. Understand? That's why we're getting 2f of 2's, 2f of 3, so on and so forth. Get the garden stuff?
Yeah.
You get a different answer?
Yeah, I get like a caution sign.
You get a caution sign?
Yeah, I get that too.
Hover over it to see what it says.
I just ignored it.
What does it say? Warning, overload.
Scalar has been multiplied by the identity matrix.
Why did you multiply it by the identity matrix?
I don't
I
even know
know.
what happens to the calculator that's
It just turned off by itself. Couldn't handle it.
Well, it's confusing.
It died.
really? Does it still work?
Alright, so let's try this again, but let's try it using a different approach. I think, is Andrea looking for you or something?
Yeah.
Standing up.
Yes, ma'am.
That's incorrect.
Where are you going?
I'll be.
Play your part out. Huh?
I would if I like
This is another example.
Oh, it's that one.
Yeah, so let's check this one out.
I mean, I didn't know. Oh, you didn't know.
What's happening here? They want a trapezoidal Riemann sum using how many trapezoids? 6, right? Now, I forgot to put in here 6 trapezoids of equal height. So forgive me for that. Okay, so I want them to be equal height. What else am I missing though? I'm missing the what? The interval, right? They didn't tell me from where to where that I want the area, right? So I need to be able to figure that out. Okay, so I need to remember what this function looks like. What is that? You think back to algebra 2. That's a parabola, right?
No, was I right?
Or a parabola, right? So it's a parabola. And they want the area bounded by the parabola and the x-axis. So how would I find that area? Now it's not just any parabola, it's a parabola opening what?
Down.
Down, right? So maybe it looks like this. Right? So how would I find the area bounded by the parabola and the x-axis? What would I have to find to know my interval? I would have to find where it crosses the x-axis, right? Find those zeros, find those x-intercepts. Do you guys remember how to do that? Sure? Okay, so let's write that down. No limits, right? So, you must find them. Right? And we know that those limits are going to just be the x-intercepts. How are we going to find them? Setting that equation, 6x minus x squared equal to 0. We want the y values to be 0 because it's on the x-axis. Do we remember how to do that? What can we take out? An x, and we're left with 6 minus x, right? So now we can apply the zero product property to where one of those must be 0 in order for the product to be 0. So when is this 0? when it's 0. When is this 0? When x is 6, right? So I know that I'm looking for the area from 0 to 6, right? And this is my A, and this is my B. Good? We're going to do this one a different way. We're going to do it kind of the way we did it yesterday, using the table, okay, rather than the summation formula. Okay, so first thing we're going to do is figure out our delta x now that we know our interval. So that's going to be 6 minus 0 divided by what? 6, so we get 1. Second thing we need to make is my table, so I can know my values of those different bases, right? So where does my table begin at? It's going to begin at 0, and then to find the next value, I need to follow the width, which is what? 0 plus 1? 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 Do I stop at 6? Why do I stop at 6? My interval, right? That's my limit there. Okay, so now we need to figure out those f of x values so I can know the different bases, right? Okay, so plug in 0. What do we get? Plug in 1. 5. Plug in 2. They should all be what kind of values? Positive, right? So the next one's what? 8. Plug in 3. 9. Plug in 4. 8. Oh my god, it's a parabola, right? Kind of like we reached our maximum. So 5 and 0, right? We know at 0 and at 6 it better be what? 0, because those are my endpoints. So it's on the x-axis, right? Cool? We're ready to find the area using the table? Let's find the area. Want to do it the long way? You want to apply the shortcut that we kind of know is going to happen? Because they all have the same what? They all have the same delta x. Let's just say delta x. Right? So we'll have 1/2 times, what's the delta x? 1 times f of 0, but we know what f of 0 is, so let's just put the numbers, right? So what would f of 0 be? 0 plus 2 times 5 plus 2 times 8 plus 2 times 9 plus 2 times 8 plus 2 times 5 plus 2 times 0? No? Why not 2 times 0? We don't use the first one twice and we don't use the last one twice, right? Those two bases are not shared between two trapezoids. Okay, do you understand? All right. So we would end up with 1/2 times, that's what, 10 plus 16 plus 18 plus 16 plus 10. So what does that give us? 10, 20, 30, 40, 50, 50, 62 plus 8, 70? 70 times 8.
Wait, what? I didn't get it. No, I got.
You got 130?
No, I didn't get it. I got 70 divided by 2, but I know I got that.
Yeah, I got 70 divided by 2
No,
also.
I know I didn't get it.
I just added all the 10s, like 10, 20, 30, 40, 50. And then
Yeah.
I added the 6 and the 6, which was 12, so that gave me 62. And then I added the 8 that I did.
Yeah.
Cool.
Okay.
So 1/2 of 70? 35? Easy? So using either method, would you still be able to do it? Okay, so let's say they just gave you this table problem and they asked for the trapezoidal Riemann sum. You should still be able to go from here to here. Now I can only use this shortcut with the 2's if I have what? The same delta x, right? Okay, if not, I would have to put that particular delta x for each base 1 plus base 2. You understand? And there will be one problem like that on your assignment, so be careful with it. Alright, so for fun, let's write down that Riemann formula for this guy, since they did give us the function. What would it be if I did it the other way on the calculator? Be the summation from I equals 1 to what? 6, and we would get 1/2 times delta x, which is 1 times f of 0 plus I minus 1 times 1 plus f of 0 plus I times 1. And that should also give us the same answer that we got down there, which was what? 25. Good? Kindergarten stuff? Got it? So this one's a little challenging to type in. So you gotta be careful, right? Make sure you don't mess that up. Ultimately, remember that it's the left Riemann sum plus the right Riemann sum divided by 2. Good? Your assignment is 5 problems. 2 of them